So on the front of your packet it says taxonomy. And what taxonomy, this word, like any onomy, astronomy, for example, is like the study of something, okay? The science of something. And taxonomy is the study of how we take living things and sort of put them in groups, in categories, and look at how they are related to each other. Okay, so that's what taxonomy is, sort of putting things into different categories. So you have some vocabulary on the next slide, and those are words we'll use later on as we get into our unit. We're not going to go over them right now, but it's there for your reference. To start off, got a quick little video here about what is taxonomy, what is classification, why do we do this?
Humans have an inbuilt need to classify the world around them. We do it with music, we do it with food, we do it with art, and that's what the science of taxonomy really does. Taxonomy is the science of naming, describing, and then classifying the living world around us. Taxonomy isn't just about naming all the species that we found, it's also about ordering them, it's about grouping them together. And we group them together based on shared characteristics. So if a group of animals show shared characters, we may think that they evolved from a common ancestor, and that's why we group them closer together. The work of taxonomists is never really done. As we discover new species, or we discover more about older known species, often these names change to reflect this new information. Nautilus are one of the groups that I look after here at the Natural History Museum, and they're a really interesting group. When you first look at the shells of these species, they look very, very similar. But if you look a bit more closely, you can see some of the differences. So the umbilicus, the central part of this, varies in shape and size. And as we notice these changes, as we understand them more, then we can change the taxonomic names around them, because this gives us a better clue to their evolutionary history. Taxonomy is never really finished. We just get a step closer to the truth. When I first started working in the museum, working on the collections, I had no idea that the taxonomic work that goes on here had so many amazing applications. Things like disease prevention, conservation, ecology, food security, pest management, and even things like discovering new drugs from deep sea animals or Amazonian plants. There really is no end to the importance of taxonomy.
All right, so there's this little, a taxonomist talking about what taxonomy is. And so taxonomy, like we said, is the science of classifying and grouping things. And humans do this sort of all the time. If you think of music, for example, you all probably like music. We can take music as a general, huge group and split it into some big, maybe categories of music. Jazz, classical, rock, hip-hop. And we have these different groups of music. But then within those groups, do we also have subgroups? Are there different types of hip-hop? Yeah. Okay. Are there different types of rock? Definitely. Different types of jazz. And we go into these different groups, and so you could listen to some artist you like and say, oh yeah, that's this type of music. That's a type of rock music, and it's heavy metal, and it's speed metal. You can classify it into small little categories. Right? And so humans do this all the time. Think about foods. We think about foods. Well, we might have, Italian food, Chinese food, okay, Tex-Mex, all these different categories of food, and then we can further, northern Italian food, southern Italian food, pastas and risottos, and you have all these smaller categories. We put things in categories sort of to make sense of them. And we do the same thing with living organisms. That's what taxonomy is, looking at the huge variety of living things that we see on the earth and trying to make sense of them, trying to put them in groups so that we can better understand what they are. Taxonomy can help us understand how organisms are similar to each other and how they're different. Help us understand how things are related to each other. Can help us understand the evolution of different species. Taxonomy can tell us a lot. So we've learned about some scientists, like Darwin, for example. We'll learn about others. One scientist that's very important in this science of classification, taxonomy, is a guy named Carolus Linnaeus. He's what's known as the father of taxonomy. He was a Swedish scientist. He really got his start in botany. You know what botanists study? Plants. They study plants. And Linnaeus was a scientist who really studied plants mostly. He especially studied plant reproduction, and he came up with a means of classifying things, putting them into groups that we still use today. Okay. He developed this system that's called binomial nomenclature. It's kind of a mouthful. Binomial nomenclature. But it's actually something pretty simple. Binomial, prefix bi means two. Like a bicycle has how many wheels? Two. Binomial means name, two name. Nomenclature means a way to name things. So a two-name system for naming things. Every living organism that has been studied by scientists has what we call a scientific name, a binomial name. And it has two parts to it. Each species gets its own name. Humans, for example, have what we call a scientific name. Our scientific name is Homo sapiens. Have you heard of that before, Homo sapiens? Yeah. Okay. That's our scientific name. Out here, these trees, what kind of trees we have? That's we would call the white pine. Scientific name, Pinus strobus. That birch over there, that paper birch, is Betula papyrifera. A sugar maple tree is Acer saccharum. The red maple is Acer rubrum. Those are different, what we call scientific names. I took a class in college about it.
I was going to say, is that all on the top of your head?
Yes, I still remember from college actually.
Wow.
Took a class, you had to learn the scientific name of lots of different trees that you would find. So, humans are Homo sapiens. Dogs are Canis familiaris. So, each species that scientists have studied gets a name like that. And they're all unique. Now, they all sound kind of weird, right? That's because they are all based in Latin, or usually based in Latin. Linnaeus came up with this idea that we should use one specific language for writing these scientific names. Does anyone take Latin here? No one takes Latin. So Latin is a language that's actually not spoken in any modern countries. It's the ancient language of Rome, the Roman Empire. Right? And so because it's what's considered a dead language, that nobody speaks it as an everyday language, it doesn't really change at all. You know, English or Spanish or Portuguese are constantly changing because people start to use new words, words change in their meaning, things like that. But Latin is sort of set. And so, also, Latin doesn't favor any one culture over another. And so it can be agreed upon by scientists from all over the world as their language for science. So that's why Linnaeus chose Latin. And so scientists all over the world can agree and use the same words. Because if you think about it, people from different areas that speak different languages might be using different words to talk about the same animal. And we might call it a horse. If you were in Italy, you might call it cavallo. If you're in Spanish-speaking country, you might call it caballo, right? You know French? What's French for horse? Don't know? You know any other languages? Horse? I don't know how to say horse in another language. But anyway, all those words mean the same thing, even though they're different words. But, okay, if we use the scientific name, we all can use the same term and agree upon it. So Linnaeus really loved Latin. In fact, his name was Carl van Lin. But he changed his name to make it sound more Latin, to Carolus Linnaeus. So he's really into Latin. Little cartoon. You say tomato, I say Solanum lycopersicum. That's the scientific name for a tomato. You say potato, I say Solanum tuberos. That's the scientific name for a potato. All right, so why do we use this language? Well, common names sometimes can be misleading. So when I say pine, a white pine tree, or horse, or tomato, those are common names, we call them. Names in our native language. But what is that?
Jellyfish.
Is it a fish?
Yeah. Well, close to the ocean.
Is it a fish?
Yeah.
It is not a fish. No. Does it taste delicious spread on toast?
Yeah.
No. So it's not made of jelly either. So it's jellyfish, even though those two words together don't really make sense. How about that? Seahorse. Is it a horse?
No.
It is not. What is it?
It's a fish.
It is a fish. A jellyfish is an animal, Megarian. Ringworm.
Ew, all those things.
It's a skin infection you can get. But guess what? It's not a worm. It's a fungal infection. It's like athlete's foot, something like that. It's not a worm. Starfish?
That's a fish.
Is it?
No.
Is it a fish?
No.
It is not.
It doesn't have to be in water though.
Is it a burning ball of hydrogen? No, it's not a star either. It's actually an animal. It's called an echinoderm. So these common names sometimes could be misleading. Here's a couple of animals. Are they real animals?
No.
They are.
Yes.
The roadrunner is a real bird.
Amazing.
A coyote is a real animal. They have real scientific names. Roadrunner is Geocossix californius. Coyote is Canis latrans. Did you guys ever see these cartoons?
Yeah.
Do you know at the very beginning, the introduction, like they show them and like coyotes chasing roadrunner and then they like freeze them? And then what do they put under them, do you know?
I don't know.
They flash like a little fake scientific name, okay? And they're like jokes. Like sometimes they've called the roadrunner Accelerati increditus. That's not his real scientific name.
Do you want us to write that?
You don't have to. Edius birdius. Okay? Sometimes what they've called the coyote. So those are kind of jokes. Why do they look like scientific names? Well, they have these endings that are like Latin endings. Also, they're written in italics and they're written in a certain way. So when we classify things, just like you can say music, hip hop, trap music, whatever you want to call it, you have different categories of music. We have different categories in living things, and they go from very broad categories like jazz, okay, animals, to very specific categories. So the very biggest group you could have is called the domain. Every single living thing is in one of 3 domains. So this is a very broad, very general group. We are in the same domain as an oak tree. So these things are not that closely related, and there's a huge number of organisms in the domains. The next group down is kingdoms. There's only 6 kingdoms. So again, these are big groups. And as we move down this list, we're getting smaller and smaller, more specific groups. After kingdom, we have phylum. Next group is called class. Order. Family. Genus. Notice there's no I in here. It's not like me, not genius, but genus. And finally, the last smallest group is species. So as we go from these really big groups down to these smaller groups, the number of organisms in each group decreases each step along the way. And how closely related the organisms are increases all the way. If 2 animals are in the same genus, they're very closely related. Like a dog and a wolf and a coyote are all in the same genus. They're closely related. Sugar maple and a red maple and a silver maple, they're all in the same genus. They're very similar to each other. Here's another way to picture this. So we skip domain. Let's go to kingdom. So if you look at this list of animals, you guys don't have this, do you? All right, so all of these animals, these are all animals, first of all. They're in one kingdom together. Kingdom Animalia, it's called. A grizzly bear, a black bear, a giant panda, a red fox, an Alberta squirrel, a coral snake, and a sea star. All those things are together in one kingdom, animals. Now, are they similar to each other? I mean, they are in some ways, but a starfish and a grizzly bear are pretty different. If we go one step further down our classification to phylum, okay, well, these things are all in the same phylum. What's no longer there? The starfish, the snake, the squirrel, the fox, all those other things that are in one phylum. Chordata. These are vertebrates. Phylum, chordata are all the vertebrates. So the sea star is out of it. The next level down, class. Class, Mammalia. What do you think that is? Mammals. So what's out of there?
Snake.
The snake. So are we getting more similar now? Yeah, now we're starting to see some more similarities. Go down another step, carnivora. Okay, that has to do with their teeth. Squirrel. Okay, the squirrel's gone. Then we go down to family Ursidae. This is the family of what? Bears, correct. So again, are they more similar?
Yeah.
Yeah, they're very similar.
What is that? What kind of animal is that? The gray one? Is that
That?
Yeah. Oh, it's a grizzly bear.
Yes.
Oh,
A grizzly and a black bear.
oh.
So Ursidae. Then we go into genus. We're almost to the end. Now the panda's out, okay, and we're just left the grizzly bear and black bear, very closely related animals. And then finally we get down to species, and how many things are left? Just one. Ursus arctos. That's the scientific name for a grizzly bear. So as we went down from kingdom to species, we're getting more and more specific, more and more closely related, and we're getting fewer and fewer organisms. All right. So you guys are going to have to remember kingdom, domain down to species, the order. So I have a couple ways to help you with that. A couple sentences, mnemonic devices. So one way is to remember this sentence.
What page is this, Mr. Ross?
Right here.
This is, yeah, the next, did I go backwards?
Yeah.
So, if you remember this sentence, I have two sentences I'll tell you. One is like the classic one from like the 1950s, I think. Dear King Philip came over for a great soup. Each letter of that stands for one of those taxonomic levels. Domain, kingdom, phylum, class, order, family, genus, species. There's also one that's not quite as nice. Dumb kids play catch on freeway, go splat. So that's not very nice, but it might help you remember it better. So, domain, kingdom, phylum, class, order, family, genus, species. And there's one other way that a lot of people like to remember it. This is a video, I don't know, we found a long time ago online. A class made it for students. It's a little song that helps to remember them. I'll play it for you. If you ask any 8th or 9th grader the Kingdom Phylum Class song, they probably will tell you they remember this.
Okay. In Mr. D class, we learned King Philip came over for good spaghetti. But we gonna do it a different way by kingdom, phylum, class, order, family, genus, species. Kingdom, phylum, class, order, family, genus, species.
Kingdom, phylum, class, order, family, genus, species.
Kingdom, phylum, class, order, family, genus, species.
Kingdom, phylum, class, order, family, genus, species. Kingdom, phylum, class, order, family, genus, species.
Kingdom, phylum, class, order, family, genus, species. Kingdom, phylum, class, order, family, genus, species. Kingdom, phylum, class, order, family, genus, species. Kingdom, phylum, class, order, family, genus, species. Kingdom, phylum, class, order, family, genus, species. Kingdom, phylum, class, order, family, genus, species. Kingdom, phylum, class, order, family, genus, species. Kingdom, phylum, class, order, family, genus.
Yeah, I did that at Mr. Arcuri's wedding. I did the worm at Mr. Arcuri's wedding, just so you know.
You did?
Yeah. All right. So one of those things hopefully will help you to remember these levels. Okay. So let's go over them here. Now you notice they didn't say one with those kids singing. Which one did they not say? What's that? Oh, domain. Yeah, they didn't say domain. Sometimes people don't teach domain. It's like a sort of a newer addition to this classification system. So, but we do teach it. So you have, if you remember the song, you got to add in domain before those other parts. So the most general, the biggest group, what does the D stand for? Domain. Raise your hand if you could tell me the next letter, what it stands for. K. Ava?
Kingdom.
Kingdom. How about the P? Phylum. Now maybe the song's kicking in. You remember. John?
Class.
Class. Someone else? Comes after class. It's an O. Alexa? Order. Bless you, Javante. Next, Zach?
Family.
Family. Joe? Genus. Not genius like me. I know I'm your teacher here and you're thinking genius, but genus. And John? Species. Good. So let's look at where humans are in this classification system. So where do we? Well, our domain is called eukarya. Yeah, these are usually in Latin, yep.
Are we gonna have to learn the Latin?
No, you're not going to have to know this column.
Alright, good.
What kingdom are we in?
Animal.
Animal. Kingdom, animal. Really, the kingdom is called Animalia, Latin, but we'll just say animal. Phylum, we are phylum Chordae, or Chordata. That is the animals with a backbone, the vertebrates. We are class mammal. Order primate. Do you know what else is a primate? Yeah, monkeys and apes are primates. Now, family is called Hominidae, and there are no other members of this family. Only humans are in the family Hominidae. Our genus is Homo. Means man. Species, what's this? Sapiens. That means knowing. So Homo sapiens means knowing man. And so when we are talking about an organism's scientific name, its binomial name, it's made up of these last two categories, the genus and the species. Our scientific name is Homo sapiens. Okay. A sugar maple is Acer saccharum. The genus is Acer, the species Saccharum. And when we write these scientific names, we write them a certain way using certain rules. So here we have 3 bears. Not the 3 bears, just 3 bears. Okay? And you see their scientific names are listed there. Ailuropoda melanaluca, Ursus maritimus, Ursus arctos. So we have to write scientific names. Well, first of all, let me ask you this. Which of those 2 bears are most closely related?
The polar bear and grizzly bear?
How do you know it, though?
Well, because they kind of look alike more, and they kind of have the same features, and they both eat meat and stuff.
Okay, you're right, but there's something else I'm telling you that will tell you they're more closely related. Joe?
Wasn't it because of the polar bear, since it was being warmer, they, like, they're close streams?
Oh, it's possible, but I'm thinking something else that's like shown here on the screen. How do I know, based on their names, that they're more closely related? John?
They both have bear.
No, they are.
Well, not quite. John? Well, no.
Well, they both have Ursius, and the panda doesn't.
Yeah, they're scientific names. Ursus is in these 2. They're in the same genus, whereas the giant panda is in a different one. Okay. So when we write these scientific names, the rules, the scientific name is made up of the genus and the species. We always capitalize the genus. But the second word is lowercaseified. I made up that word, by the way. So if you use it, you owe me 25 cents a use. Just be careful. Lowercaseified. So only the genus gets capitalized. And finally, we either, if we're using like a computer, we italicize it. If we're writing it by hand, we underline the scientific name. All right, any questions about anything we covered today? Okay, we're going to stop there in our